Agreed.
All right. So, yeah, I thought we could chat with James about sealed rust, what they, what the plans are, what the thoughts are, and how the Lang team should or should not be involved. Um, and I have some questions of my own, but maybe it's best to start out with James can just talk a little bit about, from his perspective, of what sealed rust is and what where things stand since a couple of updates and so on.
Sure, sure. I can give the short elevator pitch first, and I'm happy to dive into any details. Yeah, there's the links to the two posts. There's Sealed Rust, the pitch, and Sealed Rust, the plan. The plan is the most recent one. But in general, Sealed Rust is coming from my background in safety critical. So my history is working in safety critical areas, particularly avionics, gas detection, robotics, a little bit of chats with automotive folks. But in general, these industries are still fairly tied to qualified tool chains. So they're looking generally for two things. They're looking for a language that is well specified in that they have faith that when you spend a lot of engineering effort telling a program to do something or not do something, that it will in fact only do the things that you've told it to do and not do anything extra. But as well as having a language that is reasonably likely to exist or be usable in the timescale of 10, 20, 30, 40 years. So many of these devices that you're shipping on, for example, avionics might honestly have a service lifetime of 30 to 40 years where you're expected to still push updates to them, still maintain the tool chains that are being used by them and things like that. So there's typically a couple requirements, and different industries care more and less about different parts of these guarantees. But they're looking for a specific set of requirements that don't necessarily align with what your average user of a programming language is, but still is very important to these niche industries. So pretty much as long as I've been using Rust, my hope was that Rust could be a better language for these areas, for the many various reasons of why Rust I feel like is a better foundation for that. Probably don't need to talk too much to this crowd about that, but basically there's a lot of work necessary to have a language that is going to be both um, usable for these industries and that it meets the guidelines as the legal requirements are stated, but also be a language that the people who are in a position to choose this language or not are going to be happy and comfortable with. Since this is a large set of work that is not totally aligned with the open source project itself, we've generally started pushing these efforts under kind of the Sealed Rust name, to kind of identify those efforts through various talks with people. Well, let me just say kind of the goal is to, while I want this to happen, I want safety critical industries to be able to choose Rust. I want to make sure that we're not placing an undue burden on open source contributors, volunteers, things like that, who, if they're not in a safety critical industry, this is not of particular interest to them and could be seen as particularly high overhead. That's why generally the effort has been to try and get funding to consolidate these works in one place, and that we want to ensure that we have coordination between whatever we're trying to do to get Rust ready for a safety critical audience doesn't conflict with the overall design goals and bandwidth that the upstream Rust project has itself. So that's my
And it
short
seems
elevator
seems like
pitch.
have and
Go
it
ahead.
seems like having a foundation or some other entity that can actually offer guarantees and be someone that people pay for the fees and stuff like that would be helpful regardless.
Certainly, from a business perspective, large businesses typically love to have companies that they can point fingers at when things go wrong, and generally have a company or an entity they feel can realistically have liability for these things, that they can say this is your responsibility to fix. And if we're going to, they're willing to pay money to buy a tool from companies like this, but they have to have a reasonable amount of understanding and faith in the company that they're buying this from, that it will be maintained, someone's looking out for it, and is doing all of this paperwork and dotting the I's and crossing the T's. So definitely having a full entity rather than an open source project is definitely a must. And I'd say generally, unless it was a very large consortium of very major industry players, having an actual company at the other side of the table is also a particular plus, I'd say, for most of the customers or most of the people who are interested in using this that we've talked to.
But some of the things that you mention here, Andrew, in the blog post sound like they are pretty well aligned with goals of the open source team as well, right? Like, I mean, we've wanted, at least I've wanted, and I know Central has a proper spec for parts or all of Rust eventually, obviously, for quite a while. So if that's part of this work, that's something that would be not be a burden. It would be very welcome, I guess, to have something like this for the general project.
Yeah, I definitely think there's a lot of alignment there. There's some things like the specification. There's things like the test suite that would shake out of validating that specification against any implementation, whether it's Rust C or any other implementation, or Rust C plus LVM versus Rust C plus CraneLift or any other combination of those things. The overhead that I'm talking about is less about writing the initial spec, but more doing the full validation of that spec, as well as doing all of the paperwork that's associated with that. So there's definitely like the top level deliverables, like the validation, like the specification itself, like having some stability guarantees that are going to be some effort to get buy-in on. But then also like the additional getting it ready for consumption for people who are in these industries. Where some of them, like I said, the conversation about what goes into the spec is something that I see totally well aligned with the Lang team, and we wouldn't want to try and force that discussion ourselves, because then we're essentially forking the language, and I see that as totally a non-goal for this effort. I see Rust as being best positioned when everyone's kind of talking to make the best in one place. But yeah, all the paperwork and certification work that goes into that is definitely like the long tail of effort that provides very little value for the open source project, other than perhaps building confidence in the open source project, but is fundamentally required for people who are in a safety critical industry.
Sounds good.
Yeah, I can run down some. Sorry, go ahead, Nico.
I was just going to say that, I mean, the extent that the goals are aligned, then this certainly is an opportunity to get some funding for things like helping to write a spec and stuff like that.
Yes.
Yeah, definitely. I think there's a couple of hard prerequisites that are very aligned with the language. That's things like writing the specification. That's things like validating the specification, at least on the front end level. There are probably some things that are going to need to shake out in terms of like specification of core libraries, or even some tooling like how Rust C or cargo work, or some subset of Rust C or cargo work that are basically just enough functionality for what a safety critical user would use. I see those as being very well aligned. I'm trying to think. There's certainly even non-safety critical people that we've talked to who are very interested in parts of these particular. Sorry,
that sounds like a great opportunity to improve the Rust C guide as well, like how the internals work.
Yeah.
So this question may be naive. I'm an academic. I have no background in safety critical, so I have ideas in my head of what it means when you say specification, but it's probably not a COG definition. So it's probably something much more practically minded. So I guess one of the things I'm wondering is what kind of thing is the kind of specification that is needed for safety critical, and like to what extent would it be useful, I guess, to have academic collaboration, which I know there are multiple groups, myself included, that would be very interested, I guess, in that kind of stuff.
Yeah, so it's interesting because the safety critical specifications spend a lot of time talking about what your application and what your actual system that you're shipping needs to do. Their actual guidance on what you need to do to prove, typically this is called tool qualification. So any tool that's used as part of the engineering process is called tool qualification, whether that's a unit testing framework, a compiler, a linker, a static analyzer, anything that's taking an engineering action and putting a program in the loop is a tool that needs to be qualified to some level. Their specification for what needs to be done for a tool is actually super, super vague. But essentially, I summarized it in the last post as you need to have at an engineering level a level of due diligence performed and have a level of confidence in the tool that you're using that it will perform to the level that is necessary. So historically, languages like C and C++ and even Ada, I believe, have used a much more prose-driven specification. So like ISO C or ISO C++ is very much like a human legal document of bullet points and some examples and things like that. What we have in mind for Sealed Rust, and I will admit, a fair amount of the Sealed Rust planning is fairly open-ended. We're kind of both figuring it out and learning from people as we go. I see the human prose-driven specification as objectively less valuable than having something that can be at least partially or entirely machine-driven, whether that's some kind of formal grammar for this, whether it's some kind of proof around this. I don't think that we will pragmatically get to the point where we're able to write an entire proof for the Rust language. I think for certain parts of it, like the borrow checker, the type system components of the language that are possible to isolate and formally prove, I think having that does build confidence, and we can use that as like a composite specification of the language where we have some parts that are formally proven, we have some parts that are machine specified, and for the really hard parts, maybe we have some parts that are prose specified, those kind of things. But the more we can push to machine checkable or formally verifiable parts, I think there is understanding both from the safety critical and the academic community that these are highly valuable. But in terms of like how that scales to an entire compiler, formally specifying every single part of Rust C would be like a combinatorial explosion of very difficult, in my opinion. But I think, go ahead.
I was going to say the bar checker and like the operational semantics are probably the harder parts of the language.
Yes, but not because of the combinatorial explosion.
As compared to, for example, the parser is probably one of the easier parts.
Yeah.
To formally specify.
So I will be very honest. The goal is to be as pragmatic as possible and to lean on whatever academic research we can, and to lean on whatever best of breed tooling exists today. I'm certainly probably not the right person to be talking about exactly this. I'm certainly not a compiler engineer. I'm certainly not a language engineer. I'm very much more a systems engineer, like writing end applications here. But we're hoping to bring together a couple people in terms of people who do have safety critical validation experience. I've done tool qualification, but not for a compiler before, rather for testing and validation tools. But the hope is to bring in people who are working in the Rust language, people who are working in qualified compilers, and kind of bring them all under the Sealed Rust umbrella and find the most pragmatic, both from the time to qualification approach, as well as the what brings the most value and has the least impact for the Rust language in general, if that makes sense.
I think from my perspective, at least some of the parts of the compiler seem like things you could formally specify with not too much difficulty, like validating the AST, you could specify with denotational semantics very reasonably. Probably wouldn't be that difficult if you have someone sit down and do the work.
I think even in the operational semantics, there are large fragments that wouldn't be too difficult to specify. There are some really nasty corners like integer pointer casts and stuff like that, but there are large parts of the language where a precise specification shouldn't be too complicated. I mean, I have a whole bunch of that stuff in my head. It's just I'm not sure exactly where to write it down, and also like how to justify spending a month on doing that.
The other thing that we can kind of cheat on. So I've kind of always billed Sealed Rust as a subset of the stable language. So while I don't want to fork or diverge from Rust's goals, there are certainly some things that we could do of totally refusing to do them to make our lives way easier. For example, we have a chance to say, okay, cool. as is not allowed to be used at all, or something like that. You know, there are portions of language we could throw overboard and just say, yeah, those are rough edges. We just won't have them. Safety critical customers are much more willing to take limitation. Like, they would rather have a limited system that is well specified that they can work with and be somewhat limited, rather than having to jump through hoops. Because if there are things that we can't procedurally verify or things like that, you end up having to kick that to the end user, where you say, okay, here's sealed rust and all of it's fine except for these 12 things. Like, I could say unsafe in general. Like, if you've used unsafe code, then you must use this 16-point checklist and have a human manually check these 16 items on a 16-point checklist before, and we can make that part of our integration requirement. Like, you must have never aliased a pointer in your unsafe code or something like that. Like, there are a certain amount of things that you can even punt all the way down the road to the end engineers, but you still need to enumerate to them what they have to do. Those kind of things. So like, there's certainly a blend of validation opportunities, and how much can be automatic. Like, if you're using sealed rust, then you're good on everything. And if not, then you have to do these things. This is actually kind of what MISRA C is, in that,
Yeah, I was just
like,
thinking of exactly that, yes.
and that's actually, at the end of the day, all MISRA C is it's, you take the C specification, which is theoretically well specified and things like that. And MISRA C constrains that down to an even more limited set, where it says you must also only do these things or not do these things. My hope, ideally, is that sealed rust is MISRA rust, that there is no additional validation or additional tool you have to buy or specification you have to follow, where that sealed rust just is, where if it compiles and you're not using unsafe backdoors or things like that, that you do just, or that I should say safe sealed rust should just be MISRA rust. And if you need to opt into unsafe, yeah, maybe we have a 16-point checklist or something like that. But yeah, there's all, we'll see when we actually get to the point, because at the end of the day, the goal is to get this done in a couple of years. And if that does mean that for the first release, there are a handful of 16 or 20 or 35 review items that you need to do once before your final release, that's probably fairly understandable. Like, perfection is not necessarily the goal, but good enough has to be pretty good in this case, if that makes sense.
Yeah, I think it might be
Makes sense.
so when we add unstable features, it's usually usually fairly easy to see, like, these are the places where we are adding the gating, but doing it for things that are already stable might be a bit more difficult, and it might require more checks, because it's like you are starting from in a setting where you're removing a lot of things and then you're adding them back gradually, and that might require a lot of checks. So that might take some work.
Yeah, logistically, from the compiler perspective, I have very much the user story that the goal is to make sealed rust just one to the left of stable rust. So you have nightly, beta, stable, sealed, where sealed is kind of that, like, that's the metaphor I've been going for. Pragmatically, I'm really not sure how to achieve that totally, but that's kind of the Rust user metaphor that I've been going for, and it does seem to help to explain people what we're going for, and that you can have stable Rust, but if you then switch to sealed Rust, some of the features that you're used to may not be available. In the same way.
From a technical perspective, we would use some sort of sealed attribute or something in the stand library, and like a list of features that are sealed, and if it's not in that list, then you put on some gating. Like, if you are on the sealed channel, then this is unstable, something like that. So it would be like the unstable channel, but like a different set of features, and then you would need gating in different places for things that are already stable. That's how I'm imagining it.
Yeah, and the process that I see for that is basically, before you apply the sealed attribute to that, you need to have specified the behavior. So you have like a specification for that component, and you have the validation component for that. So basically, like, that's the step of taking something from stable to sealed, is you've done the specification work. So if anyone at any point, like if it's a really simple feature and the specification and validation for that ends up being fairly small, that's something that could be PR'd and then included in the next sealed release. But basically that sets the barrier of anything we want to include needs to opt into this level of specification and opt into this level of validation of it, essentially. So it can be a pay-as-you-go model. But yeah, we'll have to figure out what the minimum, like how little of Rust-C can we get away with sealing and have it still be a useful compiler for people in safety critical. Like, I think that's going to be like the game that we're playing for the first release of sealed Rust, is like how little Rust is necessary to be Rust. And even things like, yeah, we're not going to do lexical lifetimes. We're switching straight to Polonius, or switching straight to NLL or something. Like, we can make some choices of what is or isn't. Yeah, that kind of thing. Like it should be opt-in, and it should be very clear what the cost is to get something sealed, that you actually have to essentially get consensus on the specification and your validation of that specification.
Right, that might be more difficult when you have things like the Polonius or like whole systems that you can't really break apart reasonably into like, oh, this mod bit is on sealed, not sealed yet. Where, as opposed to, for example, some specific language feature.
Yeah, I mean, I guess there's a risk here that, I don't know, let's assume NLL was sealed, but Polonius isn't. This could mean that, depending on how things have worked out, this could mean that NLL would have to live in the compiler 3 more years, while all stable channels already use Polonius because it takes 3 years to specify and validate NLL.
Yeah, that's a good point.
Yeah, I think that's definitely a good point. Sorry, go ahead.
Really expect to keep, don't we expect a fork? We're going pretty far down a specific path here of how we would maintain a sealed Rust channel, but I'm not convinced we would be doing 6-week releases on said channel.
No, the goal for sealed Rust, or what I've been kind of setting as the expectation, is to have one major sealed Rust release per edition, basically offset halfway in between the editions. So if we are having an edition every 3 years, we'd have the sealed Rust release 18 months offset with that. Basically enough time to break in the new release and then have a sealed Rust release in there. And essentially really only aim for one major release per edition. So the channel certainly doesn't live as long. In terms of, so let me answer a couple things real quick. In terms of the specification definitely should not get down into the implementation level. For example, if from the outside perspective of the language, the behavior of NLL versus Polonius, basically if we specify the behavior of borrow checking in a certain way, and Polonius just allows us to be more permissive within the bounds, and we're refining that, you don't really validate, like for the actual like qualification, yes, you may need to have like coverage and testing all the way down through NLL, but it doesn't necessarily mean that at a language level we need to specify how NLL works, because that's an implementation detail of the compiler. So there is some ability to keep the specification higher level than that, if it basically the difference between implementation details and not implementation details. In terms of long-term support, that's definitely something I see being done by the folks that are being funded by the sealed Rust payment. So very honestly, like the qualified compiler is going to be a fairly high paid item for at least the one that comes with the sticker and the paperwork. So the idea is to drive LTS and all of this initial work for sealing through the funding that we would get for that. And that depending on how this funding happens, that anything that benefits the upstream project, like the specification, like the validation tests, would be part of the open source project. There's certain like paperwork and things like that that would not be part of the open source project, just because you can't really have an open source qualified compiler the way that the regulations are written today. You need kind of one responsible entity that's done the qualification and is basically carrying the paperwork that you do. But that being said, there's no reason that the specification itself and like the compiler validation of that specification can't live in an open source project. But the final paperwork that says, yes, we have done this, we reviewed this, as engineers, we are stamping off this work, that kind of needs to live within an entity right now. Something that can be signed off on.
We could basically take normal Rust C and run this advanced test suite on it and have it de facto validated, but without the paperwork for that, essentially.
Yes, that is absolutely the goal, is that for both academic and quality reasons, my goal, I'm going to say my goal. If we had all the money in the world, or we got all the funding from all the governments or all the companies and they just threw it at us, and we didn't have to worry about making money, the goal would be to have all of this live in the Upstream Rust project, because it gives the chance for people like academics to do serious research on what a qualified compiler means, and ideally continuously improve what best-in-class qualified compiler means. I'll go the other way, speaking pragmatically. Depending on how we can get funding for this, basically there's differing levels of what do we have to keep to be able to sell. Whether that means just the end sticker and paperwork, whether that means portions of the validation suite, whether that means some static analysis tools that go along with it. Basically, to be able to pay people to be able to do this work, we have to sell something, and we have to figure out what companies are willing to do, whether that means just joining a consortium, which means they're paying some money into this to be able to use it so they can get the sticker at the end, or whether it means that really like we need to be more selling the bigger parts of it. But essentially non-negotiable for me for be able to be part of this is that the design goals and the specification almost certainly has to be open source and part of the compiler. The kind of middle ground I could see going back and forth are things like the validation suites and things like that, or at least one reviewed quality controlled validation suite. I'd like that to be in the Upstream Rust project. It is traditionally very much a part of a sold qualified compiler set. Like if you look at what Solid Sands sells in their super test suite, which is for actually Clang and GCC, C and C++ compilers, they're essentially selling a compiler test suite. And that's what they sell to companies to get them able to use GCC or Clang for certain safety critical areas. These kind of things. These are the details that we're not super clear on. We're certainly aiming for, I think that it makes the most sense to have everything in open source and be part of an open standard for Rust and things like that. But we're really figuring out what it would take to get this project done, if that makes sense.
So it actually gives me an in on a question I wanted to ask for a little while now. What are there models, like when you listed out the languages for which qualified tools are available, you said C and C++ and Ada. Are there languages that were invented, I don't know when Ada was invented. I was going to say after the 80s, but I think Ada predates that, but let's say 90s, be safe. What are the models basically for new languages getting qualified, or new tooling, or what have you looked at that's happened recently? I don't know. Is this something anyone has done in the last?
In terms of languages, I'm not super familiar with any languages that have been qualified in recent history. There have been dialects of C and C++ that have been qualified in recent history. Basically, in the 80s and 90s, there were a couple of languages that were qualified to different levels. However, since then, the industry has more or less homogenized on C, C++, or mostly C and Ada in terms of those two dialects. There's a handful of others, and there's some tooling that has been certified since then. Things like code generation tools, where you have sort of a meta language, but most of those do end up generating at the end of the day like C, which then you feed into a qualified compiler. And even though it's like super hard to read machine generated C, they go, well, it generated C and we ran that through a qualified C compiler. So there's a lot of like controls modeling tools right now where you like specify the algorithm either visually or using some meta language, and then it spits out C, and they call that qualified because they're using a C compiler at the end of the day.
Yeah, I think NASA uses Python to spit out C code.
Yeah, there's a lot of languages that have done that, but basically they're just
transfile Rust to C.
that honestly is a thing that has been asked to me, and it's not super far out of the realm of a reasonable thing to do. And even speaking honestly, I'll be a little vague because we are recording this. There are some compiler vendors that we're talking to right now where part of the qualification plan is, and this I mentioned this in the last post, of qualifying Rust C not down to the machine code, but only to some IR, whether that's something in the neighborhood of mir. And the real target for that is for existing qualified compiling partners we are talking to, who have a qualified C, C++, or Ada backend, to have a very short hop between Rust's IR and their current existing compiler IR, which looks nothing like LLVM IR, but it's still a compiler IR, and allowing them to shorten their last mile of qualification tooling by basically qualifying, like if Ferris is concerned with qualifying Rust as a front end and a language specification, they only have to qualify a very small IR to IR transformation and then use their existing IR backend generator that is qualified for things like that. And to be honest, C is, a lot of people have been using C as that IR. Like instead of LLVM IR or mir or something like that, they've essentially been using C as an IR, which is kind of a weird thing, but that's kind of like the 80-10 hack for a lot of compiler engineers, where they go, okay, well, I'll just figure out how to make my Python tool spit out C, and then, yeah, I get that passed by a regulator, and they go, oh, it was C, cool. Yeah, you definitely reviewed all million lines of generated code, right? Like,
they kind of make sense, at least in terms of like concurrency and memory model, at least from the perspective of C's being better specified than LVMs.
Yeah, or at least C has a specification where LLVM IR doesn't.
Right.
My hope, or my personal belief, is that that's a kind of a gross hack that does work but is suboptimal, but it passes the sniff test of, at the end of the day, for most of this stuff of getting it through a regulator, your job is to prove to them that you've done due diligence and to not surprise them. Because anytime they're surprised, they're going to be very skeptical. So for just a pragmatic state, most people have been giving them C because that's what they understand. I think that this is subpar in terms of what we can offer in a safety critical environment. Although now we're getting a little bit off the track in terms of what I think the industry should be doing versus what they are doing. But at the end of the day, I do think that we can be doing better, and that just degrading down to C is not necessarily the most pragmatic or the most valuable thing that we can be doing here.
When people,
How much?
sorry, I just wanted to ask, like, if you use these tools, so presumably somebody at some point also tries to certify the code that is being compiled, right, and shipped. Like, you have to use qualified tooling, but do they qualify the output of the tool? Do they certify the output of the tool or the input?
Yeah, so into shipping a qualified product is a multi-layer item, in that you need to have done your development due diligence. All of the tools that you've used need to be of proper value. So, like, at the end of the day, like, no one expects that you could put garbage application code in, and just because you ran it through a qualified compiler, it will work. Like, it is still necessary to state requirements, do functional testing on both the source code that you use. Like, typically you have composite validation of an application where you have unit or module testing, you have some level of integration testing, you have some level of system testing, as well as peer review of your requirements, the source code, the tests that you use to validate that, as well as the end-to-end byproduct. So, like, theoretically, there are multiple approaches of this, and the use of a compiler or of a qualified compiler is only one facet of your engineering development plan, essentially, or your qualification plan. So there is still, like, additional layers in which using a qualified compiler is just one layer of that total engineering process, if that makes sense.
So backtracking a bit to things we talked earlier about, for the one thing I didn't fully follow was the NLL versus Polonius bit. So when you say implementation detail, so when so for example, if we would spec the compiler in terms of NLL and what programs it accepts and rejects, and we've now moved to Polonius. So that so the programs that are now accepted but previously were rejected, how do you deal with those in terms of the certification?
So in general, requirements writing is an art, in that you need to be as vague as possible. Like, you need to be specific enough to be useful and vague enough to not over constrain your system. So requirements writing typically comes down to how vague can I write these requirements and still be specific enough for the use case in which I'm specifying them. In that, like, when you're writing a specification, like, you want to specify what the system will do, not how it does that. So without going too deep into detail or giving too many examples that may or may not be applicable, specifying what borrow checking should do is the level of scope that we should expect to specify. But how borrow checking is done, like I did iterate over all of these types and check all of these things, is not what you should specify, because then you've over constrained your system, in that changing the system becomes a breaking change. It's kind of like the difference between API level stability guarantees and under the hood stability guarantees. Like I'll use the Rust structure layout as an example, in that like you can specify that certain types will exist in there, but their ordering may not be specified. In that, yes, you say you have a structure of this type that has been specified, but the actual layout and ordering may not be. And you may end up having to make incrementally more guarantees, like the alignment of the structure must always have this, where maybe that's something that you added at stage 2, where you say, before we didn't specify anything about alignment, but in generation 2, we do specify things about alignment. So a level 2, or like the second generation of specification, is always compliant with the original specification, because the original specification was more vague, but there may have been items that were compliant with the first generation of the specification but are not in the second iteration, if that makes sense.
Right, and this might be different from like the actual spec, where we do give like where we do make distinctions between what Polonius would accept and what like Ella would accept. Like the distinction between like the spec we have and the certification that agencies and like governments require.
Yeah, there may be certainly test cases that you write to validate the specification that will be made incorrect by switching from NLL to Polonius, because maybe you said it will reject this, but now we've expanded the definition to be more permissive, as long as we can prove that the more permissive one is still correct. So there's still refinement that can happen, and yes, we will likely have to revise our test cases, but the hope is that the specification of borrowing, for example, or lifetimes rather, it will be refined rather than be a breaking change, if that makes sense.
Right, it would accept more programs, so in that sense it's not a breaking change, but it's a new specification though.
Yeah, and certainly I think there will need to be revisions. So like, for example, if 2021 is the next edition, I would expect Sealed Rust 2021 edition to ship in roughly late 2022, still called like Sealed Rust 2021. But it's pretty well coupled to that edition. And there could be changes between Sealed Rust 2021 and Sealed Rust 2024, in that there's like refinement, test cases have to be changed. You know, all of these things need to be updated, but hopefully it's an iterative approach rather than like the first one's going to be the hardest, because we're going from 0 to something versus like a maintenance and update kind of change.
So speaking of editions, one clarifying question about that. So editions here are more like about long-term support rather than actually using the edition mechanism for what's allowed and what's not, like the technical concept of the edition, not the like something big every 3 years.
I think even the safety critical industry is willing to realize that leaving tools stagnant for a long time is a bad thing. And having a specific mechanisms for making breaking or semi-breaking changes like the editions offer, I think is reasonable. I don't think it's necessarily track at the 6-week release cycle, because most of these companies actually don't want to change their tools. Because, for example, if you're working on a piece of avionics and you update your compiler, you've now invalidated all of the testing that you've done up to now because you've changed your tool. Where they say actually it's healthy to stick with one compiler for the entire development lifecycle of the product, because that gives you the most chances to run into all the bugs that you're going to run into. And by changing your tooling, you're actually changing that. So on one hand, the additions are useful for both the breaking changing mechanisms. In terms of long-term support, I could see customers wanting to have a long-term support option, but I see that as being somewhat orthogonal to the sealed rust effort itself. I do think it is likely that Ferris or other entities will offer an LTS version of sealed 2021, but I see that as actually being much more of a fork of the language, and that you do have kind of either a fork or a branch of LTS that you're maintaining for a cost for those. And if you do find something, you would submit that upstream, like forward porting those changes. And if there are soundness fixes, you'll do your best to backport those changes. But it may just be like you announce a bulletin that says in LTS, we'll keep telling you what's broken even if we don't fix it. Because like I said, keeping that checklist of don't do this is an acceptable mitigation for a lot of these industries. Like, don't ever cast an F32 to a U32 because it's just insta undefined behavior or something like that, even if we don't backport a fix.
Right. So I think what I'm more wondering here is what would be an example of using the technical edition mechanism for something related to sealed rust.
If there was breaking syntax changes, like if we hadn't pulled in a keyword or something like that, like I don't see it being used significantly different than additions are used in stable, other than like, I plan to keep it pretty coupled to the stable editions definition of, or the stable trains edition definition, if that makes sense.
Yeah, I think.
Is it clear yet that those will actually happen? Like I thought, I'm trying to remember. I seem to remember talk that it's not, we won't necessarily have an edition every 3 years if it seems unnecessary.
I think that's a separate conversation. From what I'm hearing, it sounds like it's not using, you're not imagining using the addition mechanism really, other than for like, we want something every 3 years. It doesn't, like the syntax breaking changes, those are just the normal uses of the edition
yeah, I don't have any particular, like it really was like timeline based and having a version that doesn't change too often. And theoretically, I could see some customers being interested in having like a sealed, we qualified this library in sealed Rust 2021, and we want the same thing that like stable Rust has, where you can specify like, cool, I'll compile this crate in 2021 edition, and I'll compile this crate in 2024 edition, and I want them to still seamlessly interact. And it's especially important for safety critical people, because if they've done all this effort to validate a library, they literally do not want to touch that library, like no changes to that code. So if they can keep that code totally unchanged, then they're going to be pretty happy about that as well.
Right. So this feels more like, this feels like more along the lines of Boats' RFC with respect to long-term support, in that we already have a 3-year sort of cycle, so we'll just use that one for a different purpose as well, even though, well, they are sort of orthogonal. That makes sense, I think.
Yeah, I mean, from a technical perspective, I like, even if you still use the old code and use edition --edition 2021 on your 2024 compiler, it's still going to be compiling with the 2024 code gen and everything. So like the qualification of the old one is lost.
But well, Ralph, but I think that's true, of course, but you could also imagine that we certify it, like that at least from the point of view of the test suite and so on, you can say the behavior of 2021 code is not affected by sealed Rust 2024 in any way that we can see. And therefore, if you haven't changed your 2021 code, like it's at least an easier path to get in, right? If not,
Yes.
automatic. I don't know how much precedent there is for that kind of thing, but you can imagine that.
Yeah.
I'm not sure, but I definitely want to defer that problem until after the first sealed Rust release. But yeah, we have about 3 years to figure out how we specify that. But yeah, I'm not 100% sure about that. I haven't put that much thought into that. But yeah, I definitely see what you're saying, and that it's still using a 2024 compiler under the hood. But that doesn't mean that the front end or basically that the you could still have a compiler that respects the 2021 guarantees and things like that in the 2024 compiler. Or there might be like a guide that says, you know, if you are using 2021 edition, this is all true except for this. And maybe the 2024 compiler will still like throw a compiler for valid 2021 code if it's really like a soundness problem or something like that. But yeah, like I said, I kind of want to punt this to like, we've got enough problems for the next 3 years, but I definitely think this will be like one of the first questions when we start going to the second sealed Rust edition or things like that.
Yeah. Future James's problem.
Yeah.
One thing I wanted to jump.
Go on, Scott. I just want to give it a time check. That
one thing I was curious about from one of the previous conversations, a lot of optimization type things. How much does your hypothetical sealed Rust consumer care about like the extent of those optimizations, or are they more in the like willing to write the code a little bit differently such than they're happy with it?
So you were cutting out a little bit there, but I think I got the gist about that. So interestingly enough, most qualified compilers tend to be, they don't start life as optimizing compilers usually. Usually they start from a non-optimized standpoint, and the goal of the compiler is to be as simple and as verifiable as possible. And then you slowly start adding provable validations on top of that. In terms of what I have planned for sealed Rust, I think that the first release of sealed Rust is maybe going to be based on LLVM. Maybe not. Maybe based on someone's proprietary qualified compiler backend.
Maybe by that time we would have crane lift on working crane lift or something.
Could be.
That's probably, at least WASM itself is formally specified with operational semantics, so that seems like something that is.
It could be.
Easier.
I'll answer somewhat high level. So qualified is not one goal. There's a big difference between, within one industry, there's typically different levels. Like when you're in an airplane, the coffee machine is still qualified, but it's qualified to a much lower level than the flight control system. And even like your weather radar is kind of in the middle of those two. I don't think Rust-C is likely to be qualified to the highest level because Rust-C was not designed with qualification in mind. I think it's likely that Rust-C has done an excellent job, and the engineering practices that have gone into it, like the RFC process, like peer reviews, like testing, puts it in a much better state than a lot of other languages. But I would think that the first version of sealed Rust is probably not going to be for like autopilot systems. It's going to be for like mid-level qualification, maybe like middle-low in the avionics field where it's a little more strict, or maybe middle-high in the automotive industry where it's a little less strict. Where I think that's a more reasonable goal, but still a good and valuable first goal, I would say. And things like the language specification are not going to be different. However, I see if Rust wants to move into the very strictly safety critical areas, like the highest level of avionics and things like that, it's likely Rust-C would need to be rewritten, or a new version would need to be rewritten that is not optimizing based, that is willing to make a lot of performance and even complexity trade-offs in terms of simplicity, just so that it is much easier to qualify. But my hope is that by the time that we do that, we've laid a really strong foundation in that we have a language specification, and essentially we've set up Rust-C as the benchmark of what that can be done in terms of like we have a validation suite that works for Rust-C. So if we start writing Rust-C 2 or sealed Rust-C, that it can basically we get the first one done, and then we can start doing a rewrite or an iterative rewrite of parts of it that maybe even in the style of how Rust Analyzer is rewriting components of the Rust front end can be done in an iterative way where we can kind of hot plug components or iteratively do components or things like that, or find ways where we can write a static analysis tool that uses this new front end for validation. And then after we build up confidence in that, start working it over. So to answer your question very broadly, most of these customers don't care about optimizations and will easily trade determinism or simplicity or validation for optimizations, hands down. This might be an area where we can actually make up a lot of interesting places in things like mirror optimizations, where if we can specify in a qualified way mirror to mirror transforms or IR to IR transforms that are sound, then maybe that's a room for doing things like inlining or NRVO or things like that that could be specified on that level, and not in a really gnarly machine specific way. But this is a little more theoretical. TLDR is we'll probably avoid optimizations sort of on day one. And even though we can't lean on LLVM's optimizations, we'll probably lean on whoever's optimizations we're doing, whether it's Craneleaf's optimizations or proprietary compiler companies' optimization passes that are qualified. Most qualified compilers sit at an optimization level between 01 and 02 in terms of practicality. I know that's a super hard thing to judge.
Makes sense.
But they're not nearly as aggressive as like LLVM 03 is because they want to be predictable.
I have a dream of compiling Rust code through CompCert.
I'm not super familiar with CompCert, but yeah.
I was thinking of an Agda reference in the specification of Rust myself. That sounds close.
Yeah, I mean, one thing.
Okay, back to Nico's point that we're low on time.
Yeah, fair.
Go ahead, Ralph.
Actually, you have to go, so I think we should end the meeting. But let's, feel free to chat more on Zulip after or whatever. Thanks everybody for coming.
I'll give one last step. Sealed Rust is super duper. It's conversations. We're most plans are not set in stone. We're very willing to take opinion from people who are smarter than us, of which I count this room as everyone in this room is smarter than me at a lot of facets of the compiler, and I'm very willing to take feedback from that. That being said, we're also hoping as soon as we can get funding to start looping in the people who are already doing this work to be doing the sealed Rust work too, and hopefully be paid for that time, or not hopefully, if you're doing sealed Rust work, you would be paid for that time. So the goal is to, like I said, take the people who know the most about Rust and to know other people outside of this group who know the most about qualified compilers and to put them in the same room and make it happen. But if you have ideas, if you want to bounce things off, if anything that I've been saying sounds really wrong, it could be that I just don't understand it very well. And I will very readily admit that I don't have comprehensive knowledge of Rust, qualified compilers, all of these things. And if you ever, I've had a lot of productive talks with Nico and Central already, and I'm very willing to have more productive talks to refine this plan, because it is really a plan.
Oops.
No.
I think we lost him.
All right. Seems like it. All right. Well, I think we got the idea. I hope. All right. Yeah. Thanks, everybody.
Thanks, Nico. Thanks all.
Thanks.
Right.